Problem number 37. F is the vector field 3y squared minus 2x, comma 6xy. C is a straight line segment from -1, 0 to 0, 1. So let's just draw that picture real quick here. We're going from here to here in that direction. Part A is asking you to just do a straightforward evaluation of the integral of f along C. So to do that, we would need to parameterize. A nice parameterization of this line segment would be -1 plus t, comma t, as t runs from 0 to 1 here. When t is 0, you're at -1, 0. When t is 1, you're at 0, 1. We know for our calculations, we need r prime of t. That's 1, comma 1. We know we need f of r of t. So plug in y is t and x is -1 plus t. And so we have 3 times t squared minus 2 times -1 plus t, comma 6 times -1 plus t times t. And then finally, we know we're going to need to do f of r of t dot product r prime of t. And so this dot this just ends up being this plus this. So 3t squared. Let me just go ahead and distribute out multiplication here. -2 times -1 is plus 2. Then -2 times t is -2t. And then we'd have plus this. 6 times -1 times t is -6t. And then 6 times t is 6t squared. Combining things together, we have 9t squared minus 8t plus 2. So our integral is going to be f dot dr will equal the integral t runs from 0 to 1 of 9t squared minus 8t plus 2 dt. So this will give us 3t cubed minus 4t squared plus 2t. T goes from 0 to 1, and so we'd end up with 3 minus 4 plus 2 is 1 minus 0. So the final answer here is 1. For the second part of the problem, and then the third part said, find a potential function, and then use the potential function to evaluate it. This has a potential function because it's conservative. It's defined everywhere, so simply connected checks out. We check the cross partial derivatives. The partial derivative of this with respect to x is 6y. And hey, 6y is also the partial derivative of the first component with respect to y, so that checks. So this means that we can go ahead and evaluate, probably shouldn't say evaluate, but determine the potential function. We determine the potential function by integrating the first component here of the vector field with respect to x. We also need to integrate the second component here of the vector field with respect to y. What do we end up with? Okay, so this would give us 3xy squared minus x squared plus some function that doesn't depend on x, but might depend on y. Antiderivative to this respect to y would be 3xy squared plus some function that doesn't depend on y, but may depend on x. So when we go to combine this together, see we have a 3xy squared in each term, so we can copy that down. We have a minus x squared, but minus x squared could also be part of that C2 of x. So here's a potential function. You could tack on a plus c if you wanted to, but we're just looking for a particular potential function. This one works. Okay, so we have our potential function. So that's part B. Part C says, hey, in order to evaluate your integral, all you have to do is evaluate your original, all you have to do is evaluate your potential function at the ending point minus evaluate your potential function at the beginning point. Okay, so what do we end up with here? When we plug in x is 0 and y is 1, we end up with, let's see here, 3 times 0 times 1 squared minus 0 squared, minus when we plug in x is negative 1 here, 3 times negative 1 times 0 squared minus negative 1 quantity squared. There's an awful lot of zeros in there, and this answer ends up being 1, which checks out with the answer we had before. So we know we need to get the same answer in both parts of this. Though confession to make, this is actually the second take of this video that I recorded. I made a mistake in this part here, and I ended up with 3 here. And then I got 1 here, and so the fact that these answers were different told me I made a mistake, and I had to go track down the mistake.